This question here, we're just asked to do a couple of cross products, and I just wanted to go through a video of these just to kind of show two different ways that we can approach any of these. So in A, we're doing the cross product of this u and v vector here, 3, -1, and 0, -6, 2, and 0. So one method that we can use to do this is putting them into that matrix. So u cross v, it's going to be the determinant of the 3 by 3 matrix where we do our I, j, and k across the first row, the first vector in the second row, and the third vector in the third row. And then we do the determinant like we've done before. It's just kind of the same thing. So it's just a nice memory trick for the pattern, really, to put it into this matrix. So we're going to get I, and then the remaining 2 by 2 matrix, -1, 0, 2, and 0. And then remember, we do minus as we make our way to the right, minus j, and then 3, 0, -6, and 0, and then plus k. And then there were 2 by 2 when I cancel out that row. Oh, I'm going to use a different. Make sure I'm using the right ends there. The remaining 2 by 2 is 3, -1, -6, and 2. Right, it's just kind of a reminder of the notation here. I'm using the straight lines to indicate I want to do the determinant of the 2 by 2 instead of doing those little caps, which would just be the 2 by 2 matrix. So those are going to tell me to do all those determinants. I can see with I, this will just be 0 minus 0. And j, this is 0 minus 0. And plus k, this one is 6 minus 6, which is 0. I put equals there. And so what we actually get is 0i minus 0j plus 0k. And if we were to put that back into the vector, that's 0 for the first entry, 0, 0. We do actually just get the 0 vector for this. And you might have been able to catch that sooner if you noticed that u and v are actually just scalar multiples of each other. We would do times 2 to get from one to the other. So that's how we can calculate the determinants using this matrix. So I usually don't like all that work. So typically I'll use a kind of slightly different pattern here of just sort of throwing it in. So for the second one, I'm going to show you something different. So 2, 0, -1 crossed with 1, 4, and 7. And so what I'm going to get here is just this kind of horrible pattern, but there's some method to it. So for the first one, I'm going to start. So I'm doing the first entry. So I'm going to kind of ignore the first entries here. And then what I'm going to do is start with this times this. So 0 times 7, and then minus, and then I'll make my way to the other pair. So minus 4 times -1. And I'm going to do something similar now for the next setup. So I'm going to get rid of all the orange here. And maybe try a different color for this one. So now what I'm going to do is just kind of ignore the second entries. And I'm going to go 1 down from the first one that I just crossed out. So I'm going to have the -1 and then do the cross times 1. And then this is why it's kind of called the cross product. And then -2 times 7. So the other pair that's left. And then I'm going to do the exact same thing for the third one. Oh, it's a little, there is a pattern to it, and it does take some getting used to. So for the third one, I'm going to cross off the third ones. And I'm going to, again, make my way down from the one that I just crossed off to start with the 2. So I'm going to do the 2 times the 4. And then minus the other pair, 0 times the -1. Sorry, 0 times +1. And so what I should get from that is, what's that, 0 plus 4, -1 minus 14, and 8 minus 0. And so we get 4, -15, and 8. And so I should be able to now check this. So this is my answer, hopefully. My check is going to be to actually go back and do the dot products with both. So if I have 4, -15, and 8 crossed with dotted with the u vector 2, 0, -1, I can see I've got 8 plus 0 minus 8 is 0. Good. And I can do the other one dotted with 1, 4, and 7. So I'm going to get 4 minus 60 plus 8 times 7 is 56. And that is 0. So this works. This is orthogonal to both, which means I have probably done this correctly without making any weird little mistakes. So the trick and the pattern of doing it this way without necessarily having to write out all that matrix is you kind of look at the entry that you're at, and then you start with the thing directly below it, and then do the cross from there. And so on that last entry, the one that I crossed off was the third one because I was working in the third row here, the third entry. So I went to the one directly below it, but you have to kind of like go back to the top to get to something below. So that's will consistently get you the right cross product, but the tiniest little mistake with how you arrange that is going to get you a completely wrong vector, which will not be orthogonal to the two that you want it to be. So if you have trouble following that pattern or just kind of can't figure it out, using this is nice and foolproof as long as you know how to do that determinant. So that's the safe bet. What I did for part B is just a little bit faster.